So today we are going to look at the thermal analysis of a steel block which is carrying two different water pipes with two different temperatures. So in order to do the analysis for this kind of materials, my file is the .dmit file. So now we are going to do the analysis using the .dmit file. So in order to open the .dmit file, just go ahead and click on the open icon all the way on the top left corner of the Algor FEM Pro, and then just select the folder where you have the .dmit file. In my case it is an exercise L, so I'm going to click the exercise L and then click input file, and then here make sure you select the .dmit file and then select the .dmit file. There it is. And then select open. You can see a steel block with two holes permitting to carry two water pipes, and then in our case those are in two different temperatures. So this is a unmeshed steel block where we had to mesh them and start the analysis from the scratch. And then you can select the mesh size. The more finer you go, the much better the results are, but now I'm going to stay with the default 100% mesh. Just click mesh, and then you can see the block got meshed here, and then just make sure, just rotate it and make sure all surfaces are blocked or meshed correctly. And then once then you're done with the mesh, you have to apply the units. Go to the unit section and then select the English inches, because the construction or the design of this block has been done in the inches. So click OK, and then once you're done with the applying units, you are now good to go into the FE editor where you can apply the loads and boundary conditions. Click on the FE editor all the way on the left bottom corner. You're directed to the FEA editor where you can start working on your analysis. In order to do the thermal analysis, go to the analysis tab and then select the analysis type as thermal, and then we are going to do the steady state heat transfer one. Now once after you select the steady state heat transfer one, go to the analysis parameters and then add one right next to the convection multiplier, because we're going to add the convection loads. Then as I am running my analysis on a machine that operates on Windows 7, I have to play around with the percentage memory allocation. If the percentage memory allocation is in the 50%, which is default by the Algor, I'm not going to get the results because it's some kind of technical errors I'm going to get. So we are supposed to make sure that our percentage memory allocation is only 10% while we are running the analysis on the Algor, and that's it. We have to change in the analysis parameter tab, click apply, and then OK. And then once after you apply them, change the multipliers and change the memory allocation, now you're good to go into the material section where you can add the materials for the model. Right click, and then in our case the material is steel ASTM 514, and then here you can actually view the properties, and in the view the properties you can make sure the properties of the material are right or very accurate to your material properties, and then click apply and then OK. And then once you're done with the material, you are now allowed to apply the loads. Before start applying the loads, you have to select the select surfaces icon and make sure you select this one so that you can only select the surfaces instead of selecting the whole part. So we're going to apply the loads inside the bigger hole, because this bigger hole carries a water pipe with 65° Fahrenheit temperature. And then in order to apply the load, just make sure all the inner surfaces of the hole are selected. Pressing the control tab, and then just rotate your picture so that you can actually look into the hole and make sure all the surfaces inside the hole are selected, and then right click away from the picture, and then you will get a pop down menu. Just pass your cursor through the add section, then you can see the surface loads. Click on the surface loads, and then here the convention coefficient is 46,690, and then the ambient temperature is 65 degree Fahrenheit, and then click apply, and okay, now you can see the loads here. Yep. And then rotate the picture to the smaller hole, and then click on the smaller hole and rotate it, and then click control, and then click on this one, and then add surface loads, and then here in this convention coefficient section 93,380, and then on the ambient temperature section add 180, and then click apply, and then okay, and then rotate this picture, and I'm pretty sure now we are good to go into the perform analysis section, because we have added the multipliers, we have added the material, and then we have added the surface loads. And then go ahead and click on the perform analysis icon, and then now where you can see the actual analyzed picture. Yep, here we go. And then you can actually click and close to make sure that you see everything on it. And then these are the results of temperatures in degrees in Fahrenheit. And then here you can actually look at the applied loads inside the surfaces of the bigger hole and the smaller hole. You can create an animation here by using this create animation icon, and then it is preferable to go with the second frame rate control, because where we can get the good FPS one. Click save, and then this is how animations are produced here. And then if you want to view, you can view it now, but in this case I don't really want to view it. So, and then you can also make use of the report that is inbuilt created by the FEM Pro Algar, and then just go ahead and click on the report, where you can actually see the whole design analysis technical report with all that necessary technical information about your analysis. And then this is the actual way to do the thermal analysis for a block carrying two different temperature water pipes. Thank you for watching the video.